Um, so sorry. So in short, what the project is essentially is it's a smart pillbox, and it's by Warren Zhang. I'm currently a high schooler in Los Angeles, and Sarush and my partner, Sarush Marazi. Now the table of contents I will be going over is the introduction of the smart pillbox, the ESP, the app, Firebase, and Flash server, and also the notifications. So, this inspiration to create a smart pillbox project that's from my grandmother, who has trouble remembering to take her medicine, let's say morning medicine at 7 o'clock or something like that. And there's trouble, she has trouble remembering. And I noticed that a lot of seniors and older people have a similar problem to my grandma, and many require external assistance. What this essentially means is that they require other humans or other people to remind them to take their pills, which over time can be a grueling process. So my mission is to create efficient and easy to use tool to help people remind them to take their pills at a certain time. It can be people of all ages. And I hopefully I see this tool being affordable and widespread, especially within the senior community, because I feel like that's where the need for such a tool is needed the most. And the main problem with many current products similar to the smart pillbox is that they have apps that send notifications to remind users. However, a lot of seniors and a lot of people they don't really they're not really mobilely oriented, which creates a difficulty, especially for older seniors. So the solution to this problem would be to have a piece of hardware that people can interact with, and this is where the ESP comes in. So what is an ESP? And, the ESP that I'm using is a ESP32S2 reverse feather, as you can see on the left. In short, is a compact development board with built-in Wi-Fi capabilities, 3 buttons that will change the screen, and obviously the screen itself. The screen, in my case, is used to display different functions of the program, which are the home screen, pill count, which is the users can adjust how many amount of pills they have, and also pill reminder, which is an adjustable timer that you can add and subtract in intervals of 30 minutes. So for the first screen, it's pill count. So first of all, I set it so that button D2 on the ESP, which is the one right here, can change the screen to the pill counter screen, which is just where the user can interact with the number of pills that they have per pill. And once on the screen, button D2 is also the button used to add pills to the selected pills in the library, as you can see right here. And similar to the pill count screen, the pill reminder screen also switches screens using the D1 button instead of the D2 button, but it's all the same process. And when on the pill reminder screen, button D1 is used at 30 minutes, and in our case I just used 1800 seconds, and subtract 30 minutes using button D2. And since I have an app as well as an ESP, you would want it would be logical to connect the two since you want to share information about the user's pills. So when first using the ESP, a QR code will pop up as you can see right here. And through the app, users have the ability to scan the QR code to pair their ESP to their app account. I will go over this more in depth in a later slide. So the construction of the app was made through Flutterflow, and the contents of it are or the main contents are the home page, my pills page, and also how pills are created and pill info. So this is the home page. On the left, the home page consists of a list of the user's pills uh, and are shown in the order that they are created. And also below the pill name, there's a scheduled time that the user assigned per medicine. And this is the My Pills page. You can see it has a list of the pills, except it gives a little bit more information than the home page, as it also shows the number of pills. And you can also have the option, let's say you stop taking a certain pill or medicine, you have the option to delete said pill, and you also have the ability to add pill on the top right with the plus button. And that is how you create a pill. When the user clicks the plus button on the top right, there will be a pop-up screen on the bottom that will allow the user to enter pill name, the number of pills they have, and then time until next pill, and also the last time they took it, so we can set a schedule for them. And based on the number of pills, let's say you have 5 pills, and let's say you're taking Advil, I guess, and let's say the last time taken was today, or at this exact time, then it will cycle for 5 more days because you have that number of pills, which essentially creates a schedule for the user for their specific pill. And there's a pill info screen on the homepage. If you notice, there was an arrow next to each pill name and pill time. And if said arrow is clicked, it will lead to another screen. And since I set this pill to the number of pills to 2 times, you'll only see that, sorry, you only see that two of these pills, or two of the future times are shown, rather than, let's say, 10, because I only set the number of pills of this example pill to 2. And if a user wants to see when they have to take a pill next, they can plan ahead of time. Let's say they have dinner, they have to go out for dinner or something, so they can't take it at that exact time, so they have to double check when they need to take the pill and adjust accordingly. Now the Firebase and Flash server, this is kind of the important part where all the information is stored. So I use Firebase to store the information of pills from both ESP and Flutterflow stored in the database. And information of each pill and each pill ID is sorted by each user's unique ID from the app. And a Flash server, since Flutterflow and ESP use different timestamps, we cannot directly send information to Firebase because it won't convert accordingly with the app, which is why we have a Flash server in place to translate information from the ESP to the database. So in turn, the database can send information to the ESP, which is how the app and the ESP are able to communicate directly to each other or indirectly to each other. And the key functions of the Flask server is that it creates a unique QR code for each user, and then it also continues to check for if a user ID and a device ID have been paired with each other. And if the way that they check it is that if the QR code is scanned, then they'll pair the user ID, which is the ID that you have when you log into the app, and it pairs it with the ESP ID when you first get it. And then if the Flash server sees that they are paired, then they will stop showing the QR code screen and they will start showing home screen. So the Flash server is how ESP sends information to Firebase, and also how information is from the app is also shared between the two app and ESP. And notifications, since notifications are an essential part, is a key point of the entire product is to remind users, obviously. So notifications plays a big part and the main part of the project. And notifications are being sent to the ESP so that users can have a physical notification as well as a mobile notification through the app. Is quite complicated, but this is a entire process. On the left, you can see this is the whole this is the chart of how uh how notifications are being filtered and sent to the ESP as well as app. So the first step is that the ESP checks the server, which is Firebase, to see if there are any pills that needs to be taken within the next 30 minutes, because we set the pill reminder time or time interval to 30 minutes, so check every 30 minutes. And that if there is such a pill that needs to be consumed, the server will return true to the function for the push notifications. And then if it returns true, the ESP will display a notification on your screen. And then Firebase will tell Firebase Cloud Messaging, which is the notification part, Firebase, to run its custom function to send notifications. And when the custom function is ran, Firebase Cloud Messaging tells Firebase to activate the push notification function in Flutterflow, which is how the ESP first gets the notification, then you get it on Flutterflow through the app. And the fifth step is that Firebase makes Flutterflow run its push notification, which is another integrated function in Flutterflow that was already pre-built. And then it will send a notification to the user on the app. And the final step is that Firebase checks the server to see when the next pill is scheduled. And then this cycle repeats and repeats for the number of pills you have and the time that you have for it scheduled. And this is the 3D model. As you can see on the top right of the pillbox, the ESP can easily fit in. And with the battery, I have already 3D printed it, and the measurements are correct. It all fits. I do not have the 3D printed model on me right now, but I have checked to see. I've seen that that it works. And for the conclusion, I feel like the Smart Pillbox is an easy to use tool. The app is very easy to use as well. ESP, due to its simplicity, only has 3 buttons, is also very easy to use. Overall, the project is efficient and consistent. We have tested notifications and all notifications have been sent accordingly. And I feel like it solves many concurrent problems in many similar products, such as like the lack of physical interactions that some users may seek with their pillbox to remind them. And for future work, I think I'd probably want to make the ESP more smooth.